Okay, so let's finish off this lesson with our final couple examples. Hopefully you've had a chance to work sample problem 2, part A and B. If you haven't, go ahead and just stop right now and work these two sample problems and come back and see the solutions. So, okay, first things first, part A. Let's look at part A. My first step is to convert this to an equation so that I can see my boundary line. And so I'm going to say y equals x, and of course that's the same thing as x plus 0 if I want to get it in slope-intercept form. So I'm going to graph the line y equals x plus 0. First thing I need to do though is just take a look to see if I'm graphing a dashed or a solid line. So in this case, since it's not equal, it's going to be a dashed line. And so then I'm going to say y-intercept of 0, 0, and this is an understood slope of 1, which is up 1 over 1, up 1 over 1. Could go down 1 and back 1. And we're going to get our points to graph the line. Now this is going to be a dotted or dashed line, so I'm going to do my best to freehand that. You should be using a straight edge. You'll be using your ID as your straight edge when you do the graphing part of a test for graphing lines, so make sure you have your ID on test day. Now, I've got the line, I've got a dashed line, now I just need to test a point. Again, we run into a problem here with the fact that 0, 0 is on the line. And if you recall from the example, we used the test point 1, 1. That happens to be on the line as well. So I need to go somewhere else and just test a point that's clearly not on the line. And so what I'm going to do is I'm just going to come out here and I'm just going to test, some random point out there. And so let's just say 2, 0. 2 zeros is as good a test point as anything else. Now, I'm going to replace the x and the y in the equation with a 2 for the x and a 0 for the y. And so I'm going to have 0 is less than 2. And so 0 is less than 2 is actually a true statement. So that tells me that that point, 2, 0, is part of the shaded region. It is in the area of solutions that make this true. So I'm going to take my little highlighter function and just do the best I can to stay on this side of the line to represent all of the solutions to this inequality. Okay, and so that is the answer to that problem. That graph with the shaded part is the correct answer to graphing this inequality. And if you recall, you can actually check that on your calculator. So let's go ahead and let's just double check that. I'm going to clear out my previous graph. I'm going to get a new graph, and remember I'm going to backspace it, and I'm going to say y is less than. Notice it changed it from f of x to y. It's using f of x to represent a function, and if you use the vertical line test on inequalities, that shaded part is representing a whole bunch of repeating x values. So inequalities are not considered functions, and so the calculator actually changes it back to y, and it takes it out of function notation. So just a little for your information. So y is less than x, and I'm going to hit enter, and you can see if you hover over the graph, you can see the clear dashed or dotted lines, and you can see where it's shaded, and you can see that we've done a good job here. Okay, let's do part B. And so for part B, we're going to, again, we're going to graph this for a line of 2y plus 2x equals to 4. Now, if you don't like the 2's here, since you have basically a common multiple all the way across, you can actually divide these 2's out, giving you y plus x equals to 2. And of course, that would be real easy to convert to slope-intercept form. And so you could see here, we could simply graph the positive 2, and then it's a negative 1 for slope, so it's down 1 over 1, down 1 over 1. And I could graph that line, and we can see here that this is going to represent a solid line. Now, maybe you didn't do it that way, maybe you use the intercept form, so I'm going to come down here and go ahead and do the calculations for intercept form. And what I'm going to do for intercept form is I'm just going to solve or evaluate the equation for x equals to 0. So I'm going to say 2 times 0 plus 2y equals 4. So that's 2y equals 4 and y equals to 2. And then I'm going to plot a second point. This time I'm going to make y equal to 0. So I'm going to have 2x plus 2y. Excuse me. I got to replace the y this time. Apologize. Equals to 4. And then I'm going to say that 2x equals to 4 and x equals to 2. And so if I come back up here, you can see from the previous time I actually graphed these points already. 0, 2, which is right there. 2, 0, which is right there. And then all I need to do is draw a solid line. Whoa, that's not a very good line, is it? So obviously you need to be working with a straight edge. And I apologize for the terrible line, but it serves a purpose for right now. So let's move into testing a point. Now we can clearly see that 0, 0 is not on the line, so we're going to test the point 0, 0. So I'm just going to use this extra space down here. So if I test 0, 0, I'm going to replace the x and the y with 0, and then that's going to give me 0 is less than or equal to 4, which is a true statement. And so since that is a true statement, it will be part of the shaded region. And you can see that would be our answer. Now, let's say you want to check this on your calculator. If you come to your calculator, and I'll clear this out one more time, you notice that it's f of x, and if I come back here and I'll make it an inequality, then we have a situation where it is y is less than or equal to. Well, if you look at our original inequality, it's not in the form of y equals, and so this particular standard form inequality would need to be converted to an inequality, in slope intercept form for you to be able to graph that. And so let me back up here and get my equals to, and so that's going to be a negative x, and then that was a positive 2. I could hit equals, and then you could see that our graph is what we had in our paper. Okay, so that finishes up graphing inequalities. Hopefully you did well on that. If you have any questions, please jot them down and ask your teacher in class.